We'll get started recording here, and once again, just want to say good evening to everybody, and thank you for joining us. Hope you had a nice Labor Day weekend. Again, I'm Joe Deli Carpini, the Science and Operations Officer from the National Weather Service in Boston, and we're going to talk tonight about the August 18th tornado outbreak here in southern New England. So just to show a couple of damage pictures just to get started, and we'll show more as we go through. This was from some of the more devastating damage that we surveyed down in Scituate, Rhode Island. You can see literally hundreds of trees just snapped, uprooted, branches down, wires down, just a tremendous amount of damage. And this was rated on the lower end of EF2 in this part of Rhode Island. So we'll get to all the tornadoes and tell you a little bit about the surveying that we did. I was part of the team that surveyed from Rhode Island up into North Attleborough and Mansfield. And then we had another team separate surveyed Stoughton on up into Weymouth. So we will talk about all about that and show some radar data too. So quite a bit to talk about here. So just if you remember August 18th, really the severe weather reports were concentrated across Rhode Island and eastern Massachusetts. We had 5 tornadoes confirmed by our damage surveys, along with some other reports of wind damage kind of mixed in kind of the same areas. There was also the one tornado in eastern Connecticut. But also flash flooding was a concern too, and we won't cover it here tonight, but there was some significant flash flooding in around the Worcester area, and especially up near Lawrence and Lowell in northeast Massachusetts. On the left, you can see the rainfall estimates in excess of 2 to 3 inches, and most of this fell within about an hour's time. And on the right, you can see what's called our crest unit stream flow, and the darker colors, the oranges and reds and purples, kind of show areas where there was quite a bit of runoff, leading to some significant urban flooding. But again, the key that we always like to remind people is tornado events or environments are also flash flood environments too. So we're often kind of dealing with both of these hazards in these types of setups, and we'll get into that. So just to go over some of our key points, what we'll talk about. These 5 tornadoes formed a kind of a classic environment for New England tornadoes. There was known as what we call low instability and high shear. But most of these higher values of instability and shear were really kind of compressed down into the lower levels of the atmosphere. We call it 0 to 3 kilometers. Figure the lowest 5,000–6,000 feet really was where everything was taking place. We had a tropical air mass in place with dew points over 70 degrees. That's very typical. That helps the cloud bases form lower, and we can get the funnel to come down to the ground much easier. And we also need some sort of boundary nearby. So in this case, it was a nearby warm front or even triple point, and I'll show you that. And that helps focus that lower level spin that's kind of already in the atmosphere, kind of helps focus it in the different thunderstorms that can form up. Now, from a forecasting standpoint, the models did very well. We'll look at some of the high-res models, and in particular, what we call the new kind of frontier in forecasting, artificial intelligence. One thing we look at is the Colorado State Machine Learning Guidance. We'll show some of that. They really help pinpoint the threat even a few days in advance, but the probabilities weren't overly high despite such a favorable environment, probably because the instability was somewhat limited. The models can struggle with that. And also the time of day. Remember, this all occurred in the morning. So that probably went against what's happened in the past and just kind of knock down those probabilities just a little bit. But overall, all the ingredients were there, and the guidance did a very, very good job. Now, locally at our office, our radar warning team really did a really good job. They were on top of what we call the near storm environment, or kind of what's going on. Think looking at those SPC Mesoanalysis maps, and knowing the radar signatures to issue tornado warnings with really some excellent lead time. The only one that got away from us was the first tornado in Scotland, Connecticut, which was originally covered by a severe thunderstorm warning, and then they backed off to a special weather statement. But all of the later storms were accurately warned, and we'll take a look at that as well. So this is the same presentation, I should mention, that we also shared with our staff. So some of the stuff is a little bit internal, but I like to share it with all of you as well, just so you kind of know how we train after different events, and we're certainly using this as one of our learning opportunities. So here's a timeline of all the events on August 18th. Again, this was all in the morning, right around the morning rush hour that day. The Scotland, Connecticut tornado occurred first, a little after 7:30, and then a little after 8:30, we had the largest one of the day, the EF2, that started in Scituate, and then was an EF1 in Johnston and North Providence, Rhode Island. Then over the border in Massachusetts, around 9 o'clock or so, North Attleborough and Mansfield, that was also an EF1. And then a couple of shorter-lived tornadoes, a very short-lived EF0 in Stoughton just after 9:30. And then just before 10, there was the EF1 in Weymouth, which covered just about a couple of blocks. So, 5 tornadoes in about 2.5 hours. That's pretty impressive. And this was actually the biggest, we'll call it an outbreak here in southern New England since the November 2021 tornadoes. If you remember those, that impacted Connecticut, Rhode Island, and much of Long Island in New York as well. So we'll take a look here. This is just a quick satellite loop, and unfortunately there wasn't a lot of data available after 12:00 or 8 a.m. And this is a loop from 6 to 8 a.m. that shows the storms forming in Connecticut that then eventually tracked across Rhode Island and southeast Massachusetts. So you can see the storms really blowing up early in the morning, feeding off that low level, what we call instability, and then tracking further to the northeast. So pretty impressive for an early morning event. Here's an overall look at the radar loop too, and we'll get into a little bit more of this after, but just in general, you can see how the storms evolved. We've got kind of a small line of storms lifting up from Connecticut across Rhode Island, and then you'll eventually see on the right some of the circulations, the green against the red, as that moves up into Massachusetts too. But you can see moving into the central part of Rhode Island, something's kind of going on there on the left. You can see some what we call almost like a hook type appearance right there. You can see the couplets coming up as well. It's not synced perfectly, but you can see on the right, there's the storm couplet, the green against the reds here, moving up and eventually produce the tornado in Scituate, then moving north into Johnston, North Providence, and eventually a new circulation forms and you get another tornado up in North Attleborough over into Mansfield. So when we look at, after the fact, we like to look at these low-level rotation tracks. They actually help us focus where the potential damage is. And in this case, you can see one small area of rotation where in Scotland, Connecticut, where the one tornado was formed. But then the longer-lived rotation track is from Rhode Island up into pretty much the South Shore communities in Boston. It doesn't look too impressive in Rhode Island, but then certainly looks a lot better up here as you get toward Mansfield, Brockton in particular. But in this case, when we look through the different elevations on the radar, the strongest rotation was only present right near the ground, maybe the lowest 1, 2, 3,000 feet at most. So this is the area to the east and nearest the radar where we're getting the best sampling. It's a little bit higher here, so it wasn't capturing the true rotation that was actually happening in the storm. So just kind of an artifact of radar and being a little bit farther away from it. But in fact, you can see a fairly long-lived track here from Coventry through Scituate, up through Pawtucket, Attleborough, and into Brockton, which is really where the areas that we were looking for damage. Okay, so let's look at some of the analysis here and forecasting. So this is 8 in the morning, kind of timed out very well that this was a morning event. This is at 500 millibars, which is our level about 18,000 feet. It's our steering flow. And this is really a classic tornado environment for us. If you've seen our tornado study webinar, and it's available on YouTube, you'll recognize this as what we call a type A. It's a closed low somewhere near the Great Lakes, southern Ontario. And you can see there was a closed low just north of the Great Lakes. And this is our most common tornado setup when we're looking at the 500 millibar level. So it brings a lot of southerly flow of tropical moisture into the area, also provides some good convergence for the thunderstorms to grow. So it's overall favorable severe weather and flash flood pattern for us here in the Northeast, but by far it's our most dominant tornado pattern as well. So if we go up a little bit higher now, we're up at the jet stream level, up about 35,000 feet or so. You can see in the blue shading here, we've got an unusually strong jet stream for October coming out of the Great Lakes, diving across Pennsylvania, and then moving up through northern New England. And on the right side of the jet stream here, you can see some strong winds. These flags are 50 knots, and then the solid barbs are 10. So you've got 70 knots of wind, 60 knots of wind here. You've got a lot of air rushing through this area. So it's giving us not just larger scale lift across the whole of the Northeast, but also helping that air kind of vent out, or it's called upper divergence. So the more upper divergence you have, that gives you a lot of large scale lift across the area. So, an unusual jet stream strength-wise for this time of year. And you can see it's even actually about 95 knots across the Great Lakes. So we have a lot of energy aloft, and this was just a really, really good setup for severe weather here in the Northeast. And if we go down even to the lower levels, this is roughly around 2,500 feet or so. You can see in the circled area, we've got a lot of southerly flow coming up, a lot of moisture from these. You can see these green contours, but notice also the wind flag. So you've got a south wind here on Long Island. Roughly, it's about 25 knots or so. But up here in Gray, Maine, you've got an east wind at about 10 knots. So what that means is you've got a lot of convergence in the lowest levels in this area. This air is rushing in fast and it's running into slower air out of the east. So you're getting a lot of lift in this area. And that really is helping fuel those thunderstorms as well. Okay, so now from a forecasting standpoint, how unusual was this event? Well, actually, it was pretty unusual. You can see in the red shading here, these wind speeds, again, this is looking at about 500 millibars. The GFS Ensemble is telling us that winds of over 60 knots here are about 3 to 4 standard deviations from climatology. So in other words, from what is normal. And on the backside of this trough, when we had the really, really strong winds, remember 90 plus knots, these are 4 to 5 standard deviations above normal. So very strong jet dynamics. And so if you have any instability whatsoever, you need to watch really closely for the potential of severe weather. And we certainly ended up having that. So let's look here at the Colorado State. These are the machine learning probabilities. And this is about a day or so before the event. So these are the day 2 probabilities. Notice we've got a relatively low risk of tornadoes, but it's there. And in this part of the country, it's rare to see anything, very high. There was even a low probability of hail, especially across western New England, and more of a widespread low probability of damaging winds. So, from the pro things that we saw, we have strong wind fields and jet dynamics for August. And we know we had some instability, but things going against it, the instability was limited. As usual, our lapse rates were poor. And lapse rates, again, are just the change of temperature with height. So the stronger lapse rate you have, that helps those updrafts really grow in thunderstorms. So probably, in the time of day also, probably kept these probabilities a little bit low. And I would say the thing that really probably was the key was the limited instability. If the instability isn't there over a broad part of the atmosphere, so thousands of feet or tens of thousands of feet, it's really not going to be picked up on the model very well. Now, looking at excessive rainfall, again, a low to moderate risk for the most part, the green and yellow shading here, excessive rainfall, and from WPC, there was a low risk as well. We've got high, what are called PWATs, precipitable water. So think about it as just the amount of water that's kind of above you in the atmosphere. If everything would ring out, we were over 2 inches, which is very tropical and impressive. Dew points in the 70s. So those things were favorable for flash flooding. The cons, again, the morning timing, not the best time of day for thunderstorms. And we had very strong shear. So that can also help keep things moving along as opposed to having more stationary storms. So those two things probably kept those in the low category as well when compared to kind of past events. So another guidance source is the short range ensemble forecast. We call it as the HREF or the SREF from the Storm Prediction Center. And this was just a quick snapshot the day before, looking at what's called the tornado ingredients parameter. You can see it's definitely highlighted here over much of southern New England, and even a little bit farther to the north. This is kind of a parameter that utilizes instability and shear to kind of come up with a potential for tornadoes or even severe weathers, but tends to do very well for even the tornadic potential. And you can see here, the values aren't overly high, but for this part of the country, these are fairly decent, getting up to around 15%. Now, the HREF, the high-res ensemble forecast, is another great tool, and I think many of you are familiar with that. This showed the day before, here's a probability of a tornado within about 40 kilometers of a point. So, again, not overly high, but fairly impressive for southern New England. When you see, 2 to 5%, that's pretty good for us, and it really highlighted the area very well. It's not going to always hit it perfectly, but it puts you in the ballpark, and definitely told us there was the at least low probability for a tornado. And what all these kind of these fields tell you is you got to dig a little bit deeper and kind of really see what's going on. Okay, so let's dig a little deeper. Here's the instability and shear from the HREF. It's showing the values in blue are the surface Bay Cape or instability. You're getting close to 1,000 joules per kilogram or higher. That's pretty good. So you're anywhere between about 500 and 1,000, but note we're also on the gradient here. So you don't need always the absolute value or the real good instability down here south of Long Island. If you're on the edge of this, that's often good enough as well. So the storms can feed off of that. And notice you've got, also some decent shear values. There's a little bit of a contour there, kind of showing us the updraft helicity, which is the amount of spin. So despite the limited instability in this case, there was very strong shear present that kind of helped to compensate. We'll talk a little bit more about that in a minute. So our updraft helicity, what I was talking about, this is just the amount of spin in the atmosphere. So you can see it's very well highlighting an area from eastern Connecticut into Rhode Island. Not so much in Massachusetts, but it did show on the it did show a little bit later here, the Ensemble Max. There was some outlining there into Massachusetts as well, and it's a really good indicator of severe weather potential, where the greatest potential is. So looking at these probabilities, you'd probably say eastern Connecticut, maybe even into more of Connecticut and Massachusetts too, but certainly highlighted the area pretty darn well in my opinion, and actually showed one helicity track from eastern Connecticut across northern Rhode Island into the south shore of Boston. So pretty good for this ensemble. Okay, let's look quickly at the SPC outlook. So this was day 3. This was issued Wednesday, early morning. So notice we were in a marginal risk of 5% severe weather risk at that point for southern New England and areas to the north and just to the south. As we move to day 2, notice we're still in that marginal risk. 2% for tornadoes, 5% for damaging winds, and even a 5% probability for hail as well. So again, we're never going to really see the blockbuster, numbers like they see out in the plains, especially in these cases with limited instability. But, the stronger shear certainly adds credence to the fact that, you're at least under a marginal risk that day. And then the day 1 outlook issued early that morning kind of continued the same trend with the marginal risk in place. And in fact, we have to remember SPC doesn't go by, necessarily, how many reports are in a certain area. It's really over the whole area. So we had the 5 tornadoes, which is pretty impressive. Was that worth a slight risk? Maybe, but overall they're looking at larger, multi-state areas for severe weather and not more down on the local scale. So we take that message from them and we can amplify it a little bit, which is certainly what we did. And we can talk about that in a minute. So I wanted to just briefly talk about the triple point, if you're not familiar with that. And this was a forecast from the GFS that did pretty well. You can see we've kind of drawn in the low and the fronts, but the sea level pressure pattern on the model here is in white, and you can see the surface temperature is kind of in the purple, but you can kind of infer that there's a weak low pressure center here in eastern Connecticut. This would have been at about 11 a.m. With a cold front to the south, a warm front draped to the east, and more of an occluded front to the north. But it's this triple point here where the fronts come together that really can enhance the low-level spin necessary to form tornadoes. We saw something very similar to that in November of 2021 with those tornadoes as well. So if you have the presence of what's really called this meso low or triple point low, then it's really helping to focus that spin and help those, really help tornadoes form kind of from the ground up. That's how ours form around here, not so much from the top down. So at 8 a.m. that morning, the GFS was probably a little slow with it, but at 8 o'clock there was indeed a low here in eastern Connecticut, entering into Rhode Island, and we had our fronts to the north and to the east based on the surface plot. And again, a very classic environment for tornadoes in this part of the country. We've got a tropical air mass, and this is down here in the warm sector behind the warm front. Dew points are in the low 70s. That's the bottom number. And you've got, kind of strong convergence right in this area. You can see definitely make out a circulation. Winds out of the southeast, winds out of the east, winds out of the north. So you can definitely find that surface low right in that area. Now, one thing we also looked at were some of the buoy observations in Narragansett Bay and the nearby areas, which was kind of interesting as well. This was from 8 a.m., a little bit before the time of the first tornado there in Scituate. But as the storms were entering Rhode Island, and you can see what we call a good inflow. So, imagine the storms are out here a little bit to the north. You've got southerly winds channeling up, Narragansett Bay, and pretty strong. You've got a 28 knot gust here, 22 knot gusts here, 26 knot gust in the bay. So you're gusting 25 to 30 knots, roughly 30 to 35 miles per hour. And the winds are what we call backing to the southeast. Notice you've got southwest winds, south winds, but over here, they're more out of the southeast. And what that can do is really enhance that low level spin. You're backing those winds with height, veering with height, but out of the southeast at low levels, then turning more to the southwest and then eventually the west as you get higher up. And probably some channeling of the wind going on through Narragansett Bay too. So that's helping increase these speeds a little bit. But we thought this was probably one area too that really helped these tornadoes get going in Rhode Island, especially where the strongest one was in Scituate, really getting some good inflow coming up on those southeast winds. Okay, so looking at some of the mesoanalysis around the time the tornadoes began, our effective shear, which is essentially our spin, and we're looking, effective shear takes into account the storm depth. So this is pretty impressive, 40 to 50 knots coming up from New Jersey across Long Island into Rhode Island and southeast Massachusetts. At the same time, not a lot of surface instability. Notice it's all really south over the ocean. Not too much here overall. But it was this strong shear that really helped compensate for the lack of instability. And we've seen that quite a bit here in southern New England. If you have low cape, you really need high shear. If you've got higher cape, you can get away with less shear. So they kind of trade with one another and can compensate. So in this case, that was certainly what happened. But we really need to look in the lower levels for these types of events. So this is where we look in the 0 to 3 kilometer layer, 0 to 1 kilometer layer in particular. So if you look at our lower level instability, notice how much more there is. It's all focused here. And anything really over 75 is kind of important for tornado genesis or for tornadoes to form. So we've got, upwards, you've got a tight gradient, but upwards of 150 coming across Long Island and Block Island. So this was a case where the gradient was certainly important as well. And notice in the lowest levels, there's definitely sufficient spin. You've got over 100 units, and typically that's what we look for. 100 plus, and it probably was a little bit higher right in the vicinity of the storm. This is actually from a model and not so much an analysis, but it's based on a larger, coarser grid, so it's not really down to the neighborhood scale. So when you talk about an individual thunderstorm, it's likely these values were much, much higher, probably in excess of 150 would be my guess. Okay, so we had an upper air sounding here on Long Island in Upton, New York, at 8 a.m. And notice, it shows a lot of what we were just looking at. We've got, if we look at the instability, the cape, it's got a lot of instability, actually. If you look at the area between the red line and this dotted line, it extends all the way up. So, you've got quite a bit of instability just to the south, and that's where we know there was more instability. But even in that 0 to 3 kilometer layer, you've got, plenty of instability there, over 200 joules per kilogram. And look at the low level helicity. 320 over that, when we know, over Rhode Island, it was more like around 100 or so. But the thing to point out is, look at the significant tornado parameter. Look where the line is. It's above EF0 for the most part. These are the box and whisker plots, but it's in the range of EF2, EF3, maybe even EF4 plus. So no wonder we had an EF2 over there in Rhode Island. This was kind of right in line, definitely suggesting the potential for some strong tornadoes that morning. A lot of turning right on the lowest levels, which is very important. Okay, so how was this event messaged? Well, we had our usual emails to emergency managers, but we also mentioned in an online chat that there are some fall-like jet dynamics coupled with the cape or the instability, the possible triple point low formation, increasing low-level helicity or spin. So that kind of is where we're talking about this 2% risk, but you've got the precipitable water values closing in on 2 inches with a low risk for flash flooding. Mentioning it's an early show, the dry slot, the front or FROPA, entering by early afternoon. So Friday morning would be active with the warm front, followed by the frontal passage in the afternoon. And the storm's moving offshore, that's 21Z 5 p.m. So the early timing places the greatest risk, eastern Connecticut into Rhode Island and eastern Mass. So forecast team did an outstanding job recognizing the signals that were there, utilizing the high res guidance, and really being able to communicate, the timing of all the hazards and areas as well. So as I mentioned, we had briefings to emergency managers, and our TV meteorologist began early Thursday morning, mentioned 2 possible rounds of severe weather, including the low chance of tornadoes, and similar messaging was used on social media as well. So you can see those were right here. So, not an overall high threat, but certainly the chance for some tornadoes as well in the morning, and the storms, and possibly another round that afternoon, which actually ended up materializing for parts of the area. Okay, so at this point, let's take a look at each of the tornadoes. We'll go through them. We'll start off going through the timeline. So this is Scotland, Connecticut, the EF1 tornado. You can see the path there. It was from about 7:53 to 7:59, rated EF1 with peak winds of 100 miles per hour. The path was just over 2.5 miles, the maximum width about 200 yards, and no injuries and no deaths reported. You can see some of the damage here. We worked with the Connecticut Department of Emergency Management, Homeland Security, touring some of the damage, and they provided a lot of these photos to us as well to help out. You can see, a lot of tree damage, trees down, branches down, all, consistent with winds of about 100 miles per hour. I'd say, overall 90 to 100. So the lower end of EF1, but certainly, some fairly significant damage in Scotland, Connecticut. So, as I mentioned earlier, there was a severe thunderstorm warning issued at 6:49 a.m., which moved up close to the Scotland area. It covered, the area from New Britain just up to Storrs and Willimantic. Afterward, a special weather statement was issued, talking more about flooding concerns, but there were some signals in the velocity showing there was potential for severe weather as well. I always get nervous whenever you see these funky kind of reflectivity patterns, as we call it. There's usually something else going on besides flooding. But in this case, there was a special weather statement talking about, they could intensify and become severe. And in fact, it ended up producing the tornado. So just to get everybody going here, this is a loop, but just to show for all the radar images that I'll use, reflectivity, which is our usual, where is it raining on the left? Our storm relative motion is here on the right. Our correlation coefficient, which is where we look for the tornado debris signature, is down here. And this is called differential reflectivity, or ZDR. And we look for values near zero, or the gray values, where a tornado will form. And you can easily see here, there's the couplet. I'll let it go through again, and I'll just point it out to you. So greens are toward the radar, which are to the right. Reds are away. There's your tornado right there. We don't see anything, though, in the CC. As you go through again, we'll let it go through. You would see some sort of lowering, usually to a green or even blue, but we don't see much. There's a little bit, but nothing that's really correlated with this rotation. And even in the ZDR, you see high values, which are associated with the updraft. You don't see the grays. Some of the examples a little later, you'll see a little bit better example of that, but certainly a little bit of an appendage here, as we call it, as that circulation goes through. I'll let it go through one more time. You can see there's a little bit of an appendage, and we're up a little bit higher, I believe around 4,000 feet or so. So we're not capturing everything at the ground level, but in this case, there certainly, was a pretty strong indication that there was a tornado based on radar. And you can see here's the 753 image encircled here. So this was our strongest velocity couplet. Again, the radar is to the right, so greens are this way, reds are that way. So you've got this kind of circulation. We've got 41 knots of what we call inbound in the green, 12 knots of outbound. It's called gate to gate because they're right up against one another. That gives us what we call a rotational velocity of about 26.5 knots and a normalized rotation, which kind of takes into account the depth of the storm, of 1.1. And typically, we look for about 25 knots or greater of the rotational velocity and the NROT of about 0.8. So we've met both of those criteria. Again, no apparent debris signature. We're up at about 4,300 feet right here, but certainly supportive of a tornado. Okay, on to the big one in Rhode Island. This was the EF2 discontinuous path, 9.1 miles from Scituate to Johnston to North Providence, and between about 8:40 and 8:57 a.m. So this thing was trucking right along. It was rated EF2 in Scituate and also EF1 for the rest of the path, Johnston and North Providence. Max width was about 250 yards. That was in Scituate, and we had one injury. That was from the vehicle that was actually lifted on I-295. I'm sure you saw the reports of that in some of the video. Fortunately, not serious injuries and no deaths. So very lucky that there wasn't a lot of traffic at the time, because they probably did not see this tornado coming. I'm sure it was rain wrapped. It had so much heavy rain with it. So let's take a look at some of the damage here in Scituate. One was sent to us on social media from a drone, and you can see, pretty widespread area of devastation here in Scituate. A number of just hundreds of trees, as I mentioned, snapped uprooted, branches down, wires down over a pretty large area. And you can see, this is to the north here. It actually lifted for a little bit before touching down again. And this was right on the ground from our storm survey in one of the harder hit areas right there in Scituate. And that's going to take a long time for these trees really to recover from all of that damage. On to Johnston, there was significant damage there as well. EF1, we've got some of the shingles here on this roof were lifted off. A number of these trees, snapped, some of them uprooted. And this in particular caught our eye. This sign was bent over. We thought it was a stop sign, but turns out it was actually a road sign, street sign, that was just bent over. So that was indicative of all EF1 type damage. Winds probably closer to about 100 miles per hour or so in this neighborhood in Johnston. Interestingly enough, this area of Johnston is more elevated, and that's where we saw most of the tornado damage in Johnston and North Providence, and more of the hilly areas, not so much down in the lower elevations, which tells us very typical of southern New England tornadoes. They tend to touch down in the hills where it's easier for that cloud base to reach down to the ground. And then on to North Providence. Tree damage scattered throughout, maybe north of Mineral Spring Avenue, although there was some tree damage to the south as well. Most of it was concentrated in this one neighborhood. Branches down, again, trees down, one on a car here, couple on a couple of roofs throughout North Providence as well. So in Rhode Island, the tornado warning, actually severe thunderstorm warning, was issued first at 8:05 a.m., mentioned the possibility of tornadoes. So the first damage reports that came in were, initial lead time about 35 minutes, which is pretty good. It was upgraded to a tornado warning as that circulation was getting underway. Luckily, the folks were right on top of it. So they did get a lead time of about 5 minutes for Scituate, but much greater lead times up to Johnston and North Providence, and even up to Attleborough-Mansfield, which were included in the original warning. So this actually counted for that other tornado that would later form there. So let's take a look at the loop. This was first just looking over Rhode Island. And you can see here come the storms coming through on the leading edge here. You can see the circulation, and I'll point it out again. You've got the circulation now going just past Pawtucket, but it starts out down to the lower part. Here's the area of Scituate right there. You've got those yellows against the greens, another couplet there. Then it jumps a little bit. We start to see another couplet come through as it goes through Johnston, North Providence, and eventually ends up about north of Pawtucket, but did not damage there. But in this case, you can certainly see the debris signature as this pops up. You'll see it be tracked pretty well. And there it goes, I believe there. Yep, right about there. You've got some debris signatures going on. It's a little hard to see. There's another one there. This is following the couplet. So that's as it's going into Johnston, North Providence. But we'll zoom up on those in just a minute here. So this is in Scituate about 3 minutes before the tornado formed. This popped up very, very quickly. We have on the right, in the yellows, we've got about 43 knots of outbound. So again, the radar is up to the right, and about 20 knots of inbound. So this is your circulation. Again, it's gate to gate with those outbounds against the inbounds. You've got a rotational velocity of about 31.5 knots. The en route I'm not showing was 0.8, and we're sampling about 1,500 feet. So we're fairly low. This isn't really a TDS yet. It was more of just an artifact. There was a lot of noise around, but it will show up one scan later. But notice our ZDR, we've got some grays in here. So this is around 0, and that tells us that this is another confidence builder for a potential tornado. So this to me tells you, yeah, we're meeting that threshold for sure of issuing a tornado warning, and they certainly did from that point. If we go down to Johnston, this is a loop from 842 to 850. It's difficult to really find the tornado. We had a bunch of brief circulations emerging after the Scituate one, most notably near I-295, and I'll point it out in a minute. So it's kind of what we call recycling. In other words, a large tornado over Scituate had formed. It had lifted. The storm's kind of reorganizing itself, and then another tornado would drop down, pretty much the same one, would drop down again. So that's why we had a discontinuous path. So let's point it out again. Here comes the circulation. You can kind of see in here, you've got the greens and the reds. It's kind of tough to make it out, though. You're so close to the radar. You've got a little bit going across here, and we'll zoom in just a second. It's just kind of noisy, unfortunately. But if we zoom in to North Providence, this shows it a little bit better. We're looking up a little bit higher. We're not at the lowest scan. We're up at about 3,300 feet, but you can see here we've got 33 knots on the green, 25 knots on the red. It's gate to gate. That gives us about a 29 knot rotational velocity. The normalized rotation I'm showing here in the purple is 1, just over 1. And there's a TDS in this blue. So that's coincident with this rotation. You'll notice it's not exact in the same location. That's because this is a newer image we get every minute. This one is about every 5 minutes, so it's catching up in a ways. But this definitely was a tornado debris signature as it was over Johnston, heading over into North Providence. Okay, so moving on now across the border into Massachusetts. This was the third one. This was North Attleborough to Mansfield, an EF1 with 90-mile-per-hour winds. Its path was just over 7.5 miles, but discontinuous. A lot of the damage was just over the border, and then we saw more damage over toward Mansfield. It maxed width about 80 yards, and it was from about 9:07 to 9:22 in the morning. Here's some of the damage in North Attleborough that we saw that was kind of most convincing. A lot of tree damage in this one yard. Chicken coop was kind of damaged. Just a branch fell on it. A window was actually blown into the house up on the top, and again, a lot of these trees snapped up at the top. Some of them uprooted, and a lot of branches down as well. So all consistent with about 90-mile-per-hour winds. And in Mansfield, this was really where all the damage was. There was an air conditioning unit was pushed off its mounting on a roof of an industrial building. A lot of tree damage here. You can see these trees were kind of snapped off at the top, not a lot of really uprooted trees. One of the branches fell onto the back of window of this car. And again, you can see a lot. Really, the thing to note is a lot of twisting of the debris, which may not be so evident here, but it certainly was in person. Kind of more chaotic appearance to the damage. So for this was the original tornado warning issued for Rhode Island. So it actually gave a nice lead time of 32 minutes, believe it or not, which is fantastic. And this is a loop of the North Attleborough-Mansfield circulation. I'll let it go through, and then I'll point out you can see the circulation up here, but I'll just point it out at the beginning. You can see coming across Valley Falls, Cumberland in particular. There it is right there. Kind of splits a little bit and then reforms. It's kind of going through here and then over Mansfield again right there, and then kind of moves a little bit further and will eventually go into Stoughton as well. You can kind of see a tornado debris signature. I'll point that out again once the loop gets going. There's a lot of noise in here because we're close to the radar, but there was some indication. I'll point it out as we get started here again with the loop. You can see right there, you can see a little bit of a debris signature gets lofted into the air. Some of this is noise, and then we don't really see much more, I don't think, as it goes further up. It was just a little too close to the radar. You could argue maybe something was in there, but it's just too close. The radar is literally right next door. But you can also see the normalized rotation. There's several couplets in the area, a lot of weak ones, but that was the one that we pointed out that really produced the tornado there. So we had some questions, was this a tornado in Cumberland just over the border before it crossed over into North Attleborough? Well, we surveyed this whole area. You can see there's definitely a couplet. It's not quite gate to gate. You don't really have the low, what we call ZDR. You have maybe what looks like a debris signature. I'm not sure if this had a lot of consistency. There was a lot of noise. You could argue that, yeah, there was a debris signature, but we actually drove through this whole region and couldn't find any damage at all, not even a downed tree branch. So it's possible it began somewhere right near the state line, but we just really were not able to find any evidence to support it. So as a result, we marked the start over in North Attleborough, where we did see some of the initial damage. So in North Attleborough, this is around 9:07 in the morning. There's our couplet. We've got 22 knots of rotational velocity. Not too much normalized rotation. I didn't show it here at 0.4, but the radar is only at about 600 feet. So this is very, very low. But notice you definitely have the TDS here. And the ZDR in gray, that tells us we've got some debris. There really was no indication aloft. We went up to different scans on the radar, and this was about it. There wasn't much above that. So this is a very, very shallow circulation, probably less than 1,000 feet. And if it wasn't so close to the radar, we probably wouldn't have seen it at all. So, pretty impressive. In North Attleborough, we also had the FAA's terminal Doppler weather radar, which is located in South Weymouth. So we were looking at that as well. It had a little bit higher view at about 1,000 feet, and you can see much stronger rotation here. You've got 79 knots of inbound versus about 16 knots of outbound. So almost 48 knots of rotational velocity. That's pretty impressive. And, so in this case, we got a little bit higher look and showed, maybe the circulation was up to about 1,000 feet, but really not much more than that. Going into Mansfield at 9:19, here's the Taunton radar. You can see here's our nearly gate-to-gate couplet, about 32.5 knots. You've got the high reflectivity. Not really seeing a debris signature. This is more noise around the radar and nothing really in the ZDR field either. So, and really no indication of loft too. This was almost at about 300 feet. Very, very shallow tornado, but it certainly was one based upon the damage that we saw. And looking at the FAA radar gives a little bit better perspective. It's about 700 feet. So not quite gate-to-gate rotation, but certainly stronger. We've got a rotational velocity of 41 knots. You've got, some high normalized rotation at about 1.1. And on the bottom left here, this is called spectrum width. It's pretty much looking at the measure of turbulence in the atmosphere. And you can see right there, it's actually a pretty high value. So, if it were lower values, we might discount this as maybe a false return. But no, I think in this case, this was legitimate. And you even got a little bit of a hook or even appendage here up in the reflectivity. So a very, very shallow tornado. And again, I don't think this is one we would have detected if it was, any farther away from the radar. Okay, on to the last two. Stoughton, a little EF0 tornado, but it was in a tornado warning, believe it or not. The initial lead time was about 15 minutes. This was from the same storm that produced the tornado in Mansfield and North Attleborough. It started to track a little bit more to the east, but did produce a brief EF0 tornado. Notice just, a block, not even a block, about, a tenth of a mile long, 35 yards wide. Peak winds of about 80 miles per hour, only lasted about 2 minutes in Stoughton. And really not much damage to show you. There were just a couple of trees, few trees down in the area. But here's the radar, and roughly where that box is where the tornado occurred. You can see the circulation. Actually, it was a little bit north of there. You can see the circulation going up, and I'll point it out again. You've got your greens against the reds. Right about there is where the tornado occurred. Then it was gone. So it only lasted about one scan. Not much seeing much in the as far as a debris signature. Maybe something, but probably not. It looks more like noise, and not too much in the ZDR, although it does show a little bit there. So there may have been a TDS with this one, but it's really hard to tell. Again, you've got your strong couplet there, about 30 knots of rotational velocity. Not really no continuity with this feature, so it probably was more noise than anything else. And same with the ZDR. So, a tornado that small, we're probably not going to see a debris signature anyway. There really wasn't much in the way of damage with it. From the terminal Doppler radar, the FAA, looking at about 220 feet, it's, showing a little bit more. Again, 32 knots of rotational velocity, definitely a strong normalized rotation, almost near 2. And you're seeing some spectrum width, some increase in that. So definitely a little bit of turbulence in that area too. So all supportive of a tornado for sure. And in Weymouth, finally, the same warning. Initial lead time was about 30 minutes. It was right kind of on the northern edge of the box, but about a 30-minute heads up, which was great. At that point in the morning, we actually heard from SPC. So after a few warnings came out, they issued a mesoscale discussion. Obviously, no real, watch wasn't going to come out for this small of an area, but as the storms approached the coast, there certainly was a threat for some additional tornadoes, and really not much any long-lived. But as this line approached southeast Mass, certainly another one was possible and did happen. So another warning was issued on top of the first one at 9:45 to cover it, and here's what we had. Again, a short track tornado, only about less than half a mile. A few blocks in Weymouth, lasted about 3 minutes. It was EF1 with winds of 110 miles per hour. So, a stronger EF1 tornado, and max width of about 100 yards. And again, in this area, we got some nice photos from some friends on social media. Our friend Scott sent these. You can see a lot of uprooted or twisted trees, down trees and tree limbs too. And, here's the radar loop as it goes through. And it was close to the terminal Doppler radar, a little bit south of it. But you can, in Weymouth, we'll see the couplet go through. I'll show it again. And this was actually from the terminal Doppler radar here, I think. Yeah, it was. So you can see the couplet right about there. It's there and then it's gone. But it was on kind of the northern end, what we call a bookend vortex type storm. You can often see these on these small squall lines. They can form on the northern side. And what we're looking at here is that, again, that turbulence. And you can see there's certainly a lot of it with this couplet right there. And there it goes, and then it's gone. So that was it as far as the Weymouth tornado. And from the Taunton radar, it's not quite as apparent, but not gate to gate. It was kind of on the cusp for a warning at 25 knots of rotational velocity. We're looking just under 1,000 feet. Really no TDS apparent, but some high reflectivity. So certainly worth of a tornado warning. And as it turned out, yeah, there was a tornado in Weymouth as well. So again, looking at the TDWR, which was a little bit closer. I'm sorry, this was the Taunton radar still. We're looking at, again, not gate to gate, but definitely, spectrum width was high, and we had a very high normalized rotation. So again, that takes into account rotation throughout the depth of the storm. So a shallower storm, this is very helpful to look at that. So verification-wise, I actually did very well, and I was pleasantly surprised. There were 3 listed tornado warnings that we showed. They all verified, which was great. So what we look for when we do our verification, this actually gets reported on up at the end of each season: severe weather, winter weather, flash flood, and actually ends up, gets kind of reported for the nation as a whole, and these numbers get sent up to Congress so they know how we're doing. We look for a false alarm ratio or 0. You don't want to have any false alarms. Well, in this case, 3 warnings were issued, 3 verified. So that's a false alarm of 0, which is great. The probability of detection, you want that up near 1. You want to warn for all the events. And, preliminarily, yeah, we did. We had 7 different reports, not 7 tornadoes, but they were all warned. So we had, we were 7 for 7, which is great. And the lead time, the national goal is it's about 15 minutes. And we actually made that. We had about an average lead time, about 60 minutes. The minimum time was 5 minutes, which was that first tornado in Scituate. And we had a maximum lead time of 40 minutes. I believe that was the one that was in Mansfield. So, really, really considering, how quick these storms had popped up with the tornadoes and everything, pretty pleasing to say that, the staff did really, really well on this. And, certainly they're learning, the environments, they're learning the radar signatures and incorporating all of that. So it was a good day for warning, and, I hope that had something to do with the lack of injuries and certainly lack of fatalities from this event. So in summary, we'll go from here. 5 tornadoes formed in the classic environment. As we showed, the high-res models, the machine learning did really well. And the radar warning team, to me, did an outstanding job. Very proud of the job that they did to provide these warnings with really excellent lead time. All right, so from there, we will take a pause. I will answer some questions, and then we'll get on to our weather briefing. So let's see. We had a question from Brian. Let me just go back to the top of my question panel here. Have we ever had so many tornadoes in a few hours in Greater Boston? No, not that I'm aware of. This was probably the most, I've seen in probably recent memory. To have 5 like this, it's so close. The ones last November we had, I believe, a total of 12. Those were spread out over a larger area. But yeah, this was more, certainly more impressive for that. From Brian, as the years go on, will this activity become more common? Perhaps. We know we've got more thunderstorm days, coming up with a warmer climate, a wetter climate. It's certainly possible, but also don't forget, better technology now. We can detect these with the radar. We have your help through video, cell phones, social media. So we find out about more of them as well. So jury's up on that as far as we're going to see more or not. Brian also asked, don't recall when tornado warnings went out, did they indicate it was on the ground when this terminology was used? I believe it was in Scituate. Once we saw the signal in Scituate, the debris signature, they did put confirmed tornado on that one, I want to say. But that's rare for us to be able to do. Normally it's just radar indicated. From Bill, can you increase the radar scan rate when violent weather is present? Yes, we can. So in fact, we can scan the lowest slice, as we call it, right near the ground every minute. And that's what the radar team did that day too. We have it's an algorithm called SAILS. It's an adaptive low-level scans. It does them every minute is the most rapid, and that was what they were using that day, which is the preferred way to go when you've got a tornado environment. So yes, you'll get that lowest scan in that case. For Sebastian, what was the most recent EF2 plus for Rhode Island prior to this event? It was back in August of 1986. It was the F2 that was in Providence. So that was the most recent before that. We weren't using the EF scale at that point, but it was an F2. So it was actually right in the greater Providence area. From Sebastian, do you think with the preceding rain events we had over the summer saturated the soils enough to the point where it aided in some of the damage? Yeah, I certainly think so. That's definitely been a factor. It's been so wet that the root systems, they tend to be weakened a little bit from the really moist soils, and that can certainly cause more damage with lesser wind speeds. From Nick, is it possible the tornadoes in Massachusetts were only one or two tornadoes that just bounced a lot? It was from the same parent storm, but we do think because of the distance between them, North Attleborough to Mansfield definitely was one if you look at the radar data. It's possible. Could you have broken that up as two? Yes. But we just felt looking at the continuity on the radar of the circulation that it was more, skipping a little bit. There was actually some damage in between the two areas that I showed when we surveyed it. The other two, Stoughton and then Weymouth, those were definitely individual storms and rotations. So same parent storm, but different tornadoes from what we saw. Good question, though. And that's always a challenge for us to do when we're trying to verify these. From Robert, do tornadoes that form along a squall line typically have very short times on the ground? Yes, usually just a matter of minutes. And in most cases, unless it's a very strong circulation like we saw in Rhode Island or even over to North Attleborough and Mansfield, the recommended practice is just to issue a severe thunderstorm warning and mention that tornadoes are possible, because it's very, very hard to chase those circulations for tornado warnings. They last maybe a minute, like the one in Stoughton. We got a little lucky there. We had a tornado warning out ahead of it, but that wasn't for that particular tornado. It was the one that was in Mansfield. So, typically in that case, you do a severe thunderstorm warning. I mentioned tornado possible. From Ronald, can drones be used to obtain data in tornadoes? Well, I don't think they can fly into them, but they can certainly be used for the survey damage afterwards. Or if they're at a greater distance, certainly can be used to show them. But getting data itself, it probably would be destroyed and knocked down to the ground. I don't think they could withstand those kind of winds. But we definitely used them afterwards, and you saw a couple of pictures there. A lot of our friends in the TV meteorologists and the TV stations are certainly helpful, as well as the state emergency managers. So drones are a good thing, and we're lucky to have them because they really help us check out, the heavily forested areas that we can't kind of see on foot. Okay, so with that, those are all the questions that I see. We will